All right, everybody. So let's take a look at this one. This is actually a nice little review because you kind of already know, you actually know how to do this when it's even more difficult. You're trying to find the zeros in like what you were doing like on just yesterday's work. I didn't give you any of the zeros. You had to find them all. This time I'm setting you up with one. I'm saying, here, have a freebie. Just find the other ones. Yeah.
This where you take it and
Exactly. So that's exactly where I'm going to start. I'm going to take the zero that's been given to me. Well, actually, for number one, I mean, I could make my life even easier because I know a second zero, don't you?
Zero.
Yeah, I can pull out an X, so I might as well. So now, remember, I'm going to have 4 zeros altogether. So they're giving me -5 as one of them. I know 0 is another one because I can just pull out a 0. Pull out an X, right? So then I'd have 19x squared, 21x plus 5. All right, cool. So now what I'm going to do is I'm going to take this new one, right? So there's my 0. They're telling me that -5 is going to work in this. So let's just drop down our coefficients. 3, 19, 21, 5. And they're telling me that -5 works. Let's see. Well, what do you know? If it doesn't, that means you probably messed up. So go back and try and see where you messed up. But I already knew that was one of my zeros, so I didn't get any new answers from that, but it has set me up to find the remainder. Because now I just have a quadratic here, 3x squared plus 4x plus 1. And now I can just solve that like I normally do. Miss Savia, this is so easy. I know it is right now, but it's about to get weird. All right, so just solve that one like you normally would. I would do slide and divide. Yeah, and there's all 4 of ours. The -5 that they gave me for free, 0 that we found really easily, and then I get a -1/3 and a -1. So what's nice about this is at least you have a starting point, right? You don't have to go through that list of possible rational roots and just plug things in and hope something's going to work. They're giving you a starting place. All right, now let's try something like number 2. Oh gosh, it's a fraction. Well, remember, you know that this is going to work. You know it's going to end up being a 0 at the end if you do it right. So let's try. I don't see anything that I can pull out really easy from, like I can't pull out an X like I did in the last one. So I'm just going to drop down those coefficients. Make sure you're putting in 0 placeholders if you need any. 4, 3, 2, 1, none. What do you know? What do you know? Can you? Let's see, that would be 10x to the third minus 62x squared plus 62x minus 10. I don't think you can. You're never going to be able, even if you like rearrange them, your x's aren't going to work out. Yeah, so now I would have to go ahead and use my rational roots and hope for the best. Oh, I can plot it. Couldn't I divide everybody by 2?
Yeah.
That would make my life a little bit better. Yeah, that'll be better. Oh, +1 where? Did you guys get that? And now the hardest part is done. Now I'm just left with this, the x squared minus 26x plus 5. But that's a quadratic and I can solve that whichever way I so choose. So I'll do complete the square because a is 1 and b is even. Move c to the other side, right? Half of b squared 169, add that to both sides. Okay, 164. What do you? 2 root 41. Weird. Well, I can just add that 13 over. Oh, positive negative. And there we have it. I was supposed to get 4 answers and I got them.
Just say you're right. Right now.
Did I mess up? Oh, gosh, darn it. Oh, I just wrote a 1. Oh, but that messes up this. Gosh, darn it. Oh, I'm a silly goose. Why didn't you tell me that like 5 minutes ago?
I was trying to figure out.
Fair enough. I goofed. All right, so now if it's a 5, oh, I can factor by slide and divide. I'm so happy that this term, this way has a like name now. Now we have them. Did you get 1/5 and 5? So annoying to do it with fractions, yes. Impossible, no, not at all. Especially because you know that the answer is going to come out nicely. But now I want to turn your attention to something like, let's see, do I want to do number 7? Or do I want to do, let me just see what the ones on the back look like. Let's do, let's start with 11. So I know I'm going to have 4 answers altogether, right? I claim you actually know 2 of them. They gave you 1, but you know another one. Not this time.
Which one? Number 11?
Yes.
-2 minus 1.
Right. Now your, huh? So remember that these complex numbers, right, whether it has an imaginary piece or an irrational piece, they always come in pairs. So if that's a 0, so is its conjugate pair, -2 minus root 13. So you already have 2 of the 4 answers. How nice. Here's the problem though. I don't know if the remaining 2 are going to be rational, or they could be another pair of irrationals. I have no idea. So what do we do? So you could go through plugging in factors of the, you could test all the rationals and see if it works. That seems, it seems like it would be a huge waste of time, especially if I don't end up having rational answers. Now I'm really in a pickle. So, anybody have a thought? What could I do? Evan?
You could multiply the 2, get a quadratic, divide the.
You absolutely could. So there's 2 real different ways that you could go about this. One of them is exactly what he just said. So you can, these are zeros, right? So you can figure out the polynomial that these 2 zeros come from, which we know, is it still up there? Yeah, right there, standard, right? X squared minus the sum of the zeros plus the product. So you can do that to find out that quadratic. And then you can take that quadratic and divide it into the original and see what's left. Or you can take one of these zeros and plug it in and do synthetic substitution with one of these numbers. It's just a little bit weirder. So it's up to you what you want to do. So how about I do one each way, and then we'll see what we like better. Okay, so first, why don't we, let's go Evan's route, and we will figure out the polynomial that goes with this. So I need to find the sum and the product of these 2. So the sum would be a -4, and the product would be 4 plus minus a 13, -9. Is that right? Double check me. Do we agree so far? Okay, so that's this quadratic right here is what produced these 2 zeros. So what I can do is I can take my big old thing and I can divide it by this. And whatever is left over, that'll be something much smaller that I can find the zeros of a lot easier. So since that's a quadratic, I'm going to have to do long division. I can't do synthetic now. So why don't we go ahead and take that, and I'm going to divide it into my original. Make sure I'm not missing any 0 placeholders. 4, 3, 2, 1, none. Okay. And now I just go through. So that'd be a 5x squared. Remember, this is supposed to end up with a remainder of 0. So if it doesn't, something's wrong somewhere. Remember, you multiply through, but then you have to subtract everything. So it worked for me. I hope it worked for you, that you end up with a 0 remainder like we knew we should have. 'Cause these were zeros that they gave to us. They're like, hey, this should work. So as long as you didn't mess up on any of the pieces so far or the division, you're good. And now look, I have a quadratic and I can solve that easy peasy. And we get lucky again. I can do slide and divide. You do whatever you do. We got them. So this time it did happen that the remaining 2 zeros were rational. So they would have been in that list. So if you had made that list of all of these factors divided by all of these factors, these two would have been in there and you could have found them that way. But I caution you against that because what happens if the other two just aren't rational? Now you're going to go through every single one of those numbers and you're not going to save yourself any time. Okay, so it's a gamble. You think you're gonna get lucky and find a rational one, then you go for it. If there's only like, let's say like the end number was 1 and the leading coefficient is 1, you could only be 1 and -1, that I would do, right? But if there's a whole long list, I'm like, I'm not wasting my time with that. If there's like 2 or 3 numbers to plug in, all right, I might try it. Okay, let me show you an alternative option. Let's go with number 9 to do this alternative option. You can also just take the 0 and do synthetic on it. Plug it in. It's going to look real weird and messy, but it'll work. So remember, you have 2 zeros. 2 plus root 39 works, and so does 2 minus root 39. So let's see. So I'm going to take all my values. I'm going to give myself plenty of space here. And I'm going to take one of my numbers. It really doesn't matter which one. And I'll just use the one that they gave me, 2 plus root 39. All right, watch the magic that happens here. It's wild. So take the number out in front, multiply. Now this is a binomial, so you're going to have to multiply 3 to both of them. So that's now going to be a 6 plus 3 root 39. Okay, you with me so far? Now let's add these together. So that's a -4 plus 3 root 39. Now I got to FOIL these beasts together. Okay. So I'm going to do my work down here. So there's -8. Outers would be a plus 6 root 39. Inners a -4 root 39. And then the last would be 3 times 39, 117. So that gets me 109 plus 2 root 39. So far, so good. I got to add these two together. So that's going to be, what's that, -5 plus 2 root 39. FOIL these two together. let's double check each other as we go. I'm getting 68 minus root 39. Yeah, you guys got it too? All right, add them together. Boil that. Minus 2 root 39 negative 35, which is what I should have gotten. Super annoying, right? I get you. However, watch what you can do now. I have another 0, right? I know that 2 minus root 39 works. So I can keep going. Let me erase my scratch work here. And I can just pick up right where I was. These are my new coefficients. I don't need this one anymore. And now I'm just going to plug in the 2 minus root 39. And this will actually come out really nice and cleanly. Let's watch. So put in a 3, multiply that through. I get 6 minus 3 root 39. Look what happens. Look what starts to happen. All those roots start to cancel with each other. So I just get a 2. That's not so bad. And then I do 2 times that. That's going to get me 4 minus 2 root 39. And those, you see how they cancel? See? So it's not great in the beginning, but it eventually works out pretty nicely. So it'll be a negative 2 plus root 39, which cancels the whole thing. I'm left with a remainder of 0, just like I should have been. And now I'm down to a quadratic where I can finish. They're both annoying, right? It's just, do I want to take annoying road number 1 or annoying road number 2? If you're really good at synthetic and you like plugging in the weirder numbers, you can do that. If you don't like it and you're like, you know what, that's weird to me, I don't want to do it, you can go this road, find that quadratic, and then do a long division. Okay, oh, we should finish, right? Because I'm not quite done yet, but I'm close. I'm down to a quadratic. That's 3x squared plus 2x minus 1. I can do slide and divide, can't I? All right. I love when that happens. So my other ones are -1 and a positive 1/3. And I have all 4 that I was looking for. I found them. Thoughts, concerns, worries. Don't be. The imaginary works the exact same way. So you run into the same situation. You can go ahead and find either the quadratic and then divide it in, or you can do the long division, synthetic. Your call, whatever you prefer. So which one, you want to do 10 together? I have no more room, but I can do it on another piece of paper. And which way do we think we like better? How we did 11 or how we did 9? 11, yeah? Okay, so let's try that with number 10. So first of all, you automatically know your second 0 is 1 minus 3i. Okay, let's go ahead and find that quadratic. I need the sum and I need the product. Sum is just 2. The product is would be a minus 9i squared, but you know that I squared is really -1, so that turns into a 1 plus 9. So I'm getting 10 as my product. Yeah? So that means that's coming from x squared minus 2x plus 10. So that's a polynomial that evenly divides into my original. So now all you got to do is sneak in there and do your long division. Make sure you're not missing any placeholders. 4, 3, 2, 1, none, and then we just go for it. Did you get the remainder of 0? All right. Go ahead and take that quadratic and solve it. Get your remaining 2 zeros. What number is this? Okay. All right. Okay, so I'm going to assign just a few of these for you. Let's do numbers. How about 5, 7, 8? You have one of each. 5, 7, and 8. Okay, just those 3. You got a good 10 minutes. If you're fast, you might finish. All right, let me go. You left your phone somewhere? Okay.